Okay, so today is this is the second part, or the second attempt at the first part, which because we have one class at 8 and one class at 11 this week, or every week on Mondays. This is fall 2022. Anyways, today we're going to talk about the three-way switch. Um, oh yeah, there's going to be a quiz, and the quiz is going to be released later on this evening. So, well, you can start writing it this evening as soon as it's released, but the official starting day will be tomorrow morning. So, yeah. So, and the quiz is going to be the way it all my quizzes and tests are so far. So, when is it due? I'm going to make it due. It's going to be Tuesday till Friday, so the end of Friday night. All right, so let's talk about switches here. You know what? The last time I drew it, but I just got an idea. Let me see if I can bring up the multi-sim here. And it's going to be a little bit better. So just give me a couple seconds here. There we go. You should see the multi-sim screen right now. If you don't see it, screen. All right. So let's talk about first something that's called a single pole, single throw switch. Single pole, single throw. Okay. Let's see what happens if we bring up place component and all groups and we're just going to go SPST, single pole, single throw. That's what we get on the screen. So let's bring this thing up and let's put it on. All right, so and of course the name of the switch is switch 1 because that's the way the multi-sim automatically does that. And key space, that means that I can use space bar to operate that. If I press space, it's going to close the switch here. Okay, there we go. Or I can just click on that. All right, so we have two terminals, terminal 1, terminal 2, and we have the pole. And the pole we can open or close, so we can throw it only onto single way. So here's a single pole, single throw switch. Got it? Got it. Okay, now let's take a look at something like single pole. All right. So it's going to be single pole right here, just like that. And let's add one more terminal here, so we can throw it two ways, one way or the other. So we're gonna do it double throw, double throw, single pole, single pole, single throw, or single pole, double throw. Well, let's see what the multi-sim brings us here. Insert component. Let's go single pole, double throw. Oh, look at this. This thing's getting really interesting now here. All right. So here is the single pole double throw, and the name S2 is just the name of the switch that multi-sim consecutively names the switches, so don't pay attention to that. And key is space, which means I can use space to operate that switch. I can just use the mouse. All right, so here's a single pole, and here's the common terminal, and there are two positions that I can throw this pole to. So here is a single pole double throw switch. I can throw it here or here, as opposed to single pole, single throw switch. Right? I can only throw it into a single terminal here. There's no any other terminal, right? So there you go. Oh, multi-sim. I love it, multi-sim, when they do that. As soon as the mouse hits the one of the sides, this thing starts moving about. Very annoying, multi-sim. All right, so here, single pole, single throw, and single pole, double throw. All right, just for kicks, let's just go place component and do something else. Let's go double pole, double throw, double pole, double throw. Oh, look at this. We have something. We have something going on here now. What happens? What happens here? Oh, okay. We have two poles. Here's pole 1 right here and pole 2. And if we operate that switch, it's throwing itself that way. So there's double poles and double throws. The poles can be thrown into also. So here is the the double pole double throw. It can also be represented as something like this. Let me just get a pen here, and let's say we have two poles here, and um, here's a terminal, here's a terminal, uh, here's a terminal, and here's a terminal, and well, it's basically the same thing. I'm just showing you here, right? So once you operate the lever, there you go. It goes up or down, and this is just a way, another way of representing it. If I can bring it up here, all right? So now, what we're going to concentrate on is this little guy here. This one here, double pole, single pole, double throw. So we're going to get rid of that. I'm going to get rid of that. And we're just going to concentrate on this guy right here. Single pole, double throw. Okay. Now, if you had a multimeter, you know what? What I'm going to do is just going to get rid of this labeling here. It's just properties, display. Let's display nothing here. Okay. All right. If we had a multimeter, let's bring a multimeter. Multimeter. There we go. And we're going to set up the multimeter. I'm going to double click on that. And let's set it up as a ohm meter. Cool. So here's the multimeter, and here is our display of that multimeter. And how did I get that? I just double click on this. Boom, and I have the display set up. Let's make it bigger. All right. So do we still have the zoom here? Can you guys see me on the screen? Something happened in my computer. Okay, good. All right. So great. Thank you very much. So if you had those switch like this, and let's say there we go. Let's say that's what happened. Let's say this one terminal of the switch here, this one here that is common to both to the poles. Here's the pole, and here's one terminal, and here's the other terminal, and it can go this way or that way. All right. Let's call this one a common terminal. Okay, and this other two terminals of this switch, we're going to call it a traveler terminals. All right. Traveler or traveler, which is correct? Well, one is the UK version spelling, and here's the US version spelling. So if you see documentations from US, you're going to see a traveler with one L. If you see the Canadian or from UK, it's going to be with double L. So Don't panic if you see one way or the other. Right? So these are the traveler terminals. Let me just get rid of that, delete layer here. Okay, good. All right, so if you connected a multimeter, if you just had a multimeter and you had a switch, just like the switch that we used to, that we looked at, here is a switch, and here is the lever on that switch. We can flip it up or down, okay? And here is one screw terminal, here is one screw terminal, and here is another screw terminal, and it's called three-way switch, which is the single pole double throw. But in the electrical industry, they're calling it three-way switch because we can get three ways into that. Way number one, way number two, and way number three. There are three connections that we have. Also, some of the switches are going to have a bonding terminal here or grounding terminal, and some of them won't. The reason for that is that sometimes you have to connect the bonding terminal, and sometimes you don't have to connect the bonding terminal because the bonding is done through the EMT, electrical metallic tubing. So let's say you have a box and you have EMT metallic tubing going to another box with wires in them, and you have that box grounded or bonded. It's connected to the bonding terminal right there. Right? So because it's an EMT, if it's AMT, electrical metallic tubing, it's all metal. So the grounding or the bonding is carried on through the metal to another box. And from that, if it's still EMT, it's going to be carried on to another box and so on. So the only thing you have to do is you have to ground or bond the first box, and then you can carry that through the metallic tubing as the ground. So then here are the mounting brackets for this with those mounting screws, holes. Then when this metallic bracket touches the box for here from top and the bottom or left and right here, and here's the switch, okay, then this here, because it touches the metal parts, these two things are touching that metallic box, that makes the switch bonded or grounded. In Canada, okay, if you go to the from what I know is the electrical code in the states that even though it's metallic tubing, you still have to run a separate wire inside and connect it to all the bonding terminals. Okay, so that's, now those things might change with time, who knows, but at this point, 2022, that's the way it is right now. Right now, that's only if it's EMT. All right, if you have a PVC tubing, then of course you're going to have to run a conductor, grounding conductor, which would be green or bare copper. Well, it's going to be a green jacketed if it's a tubing, and then you're going to have to connect all the bonding terminals to the bonding terminals on the boxes, and then from that, this bonding terminal has to be connected to the bonding terminal on the box. So that's if it's a PVC plastic, okay? Anything other than metal, obviously, because anything other than metal doesn't conduct. So we're going to have three terminal screws. So forget the bonding for now. And if they were not labeled, how would you find out which one is which? So basically, what we need to find out which is the common terminal, and the other two are going to be the travelers, just like the traveler, someone who gets on the plane and travels to another country or something like that. That's the same word, traveler. So here's a common, traveler, and traveler. Okay, so how would we by using the multimeter, how will we find out which ones are which? Basically, we're trying to find the common. Okay. Right, so well, it works better if the class is in person, but since the class is not in person, I'm just going to have to help you a little bit, because I can just say, can somebody speak up, blah, 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 blah. If you want to speak up, go ahead, go on voice. It's going to be quicker. How would you connect that multimeter to find out which is the common and which are the travelers if they were not labeled on the chassis of the switch. All right, I'm not gonna wait too long. Nobody speaks up, so I'm going to just tell you. That's the beauty of the online thing here. All right, so if it's an ohm meter, if we had a connection, let's say, I'm just gonna connect that wire right up to the common. Well, I don't know if it's common or not. I don't know. And well, here, no, I can't do that. Can I do this? Can I hide it? That's gonna be interesting. I don't know. That's the only thing I can do. No, all right, not gonna hide it. Okay, so let's say between common and any other terminal. All right, and then let's just close that. All right, we have 0 ohms, and if you had it on continuity, you would have a beep going on. That's what we beeping, right? Now, let's flip the switch. All right, we're going to have the, well, it says 99.9 the mega ohm, so let's say infinity, all right? So you're going to see the OL over limit or overload or whatever on this digital multimeter. Okay? So that means if you keep flipping the switch and you're getting different readings, you're getting continuity on one of them. That means one of them is common. All right. Okay. Well, let's stop the simulation, disconnect that one, and connect it to the other one. Right. Continue the simulation. Oh, we have the infinity here, so there's no continuity. Well, let's flip the switch. Oh, we have 0 ohms here. So that means when we switched it from that, these two must be travelers and this one must be common because that's the one that we haven't changed. And the other thing is, what you could do is keep connecting things, and there's not too many combinations, until you find the two travelers. If you find the two travelers, let's say start the simulation, we have the infinity, okay, huge resistance. No matter which way we flip the switch, all right, we're not going to have any change of the reading because these two are never going to connect no matter which way you flip the switch, which means the one that we have not connected must be the common and the other two must be travelers, right? Okay, so that's as far as the multi-sim goes. Let me just stop the simulation so we don't get all right, I'm just going to minimize that. All right, now let's talk about what is a closed circuit. I'm pretty sure all of us know already what a closed circuit is, but let's just get the analogy going. So here is a power supply. Let's say it's a DC power supply. And we have a wire going through and a conductor going through. And let's say this thing is going into a light bulb, which would be a load. A resistor would be a load. An inductor would be a load. A capacitor would, could be a load. But we're just getting a light bulb here. Now, let's see which way the electricity flows. It goes this way because let's assume the conventional current flow for this purpose. So this is the positive side and this is negative side of the power supply, and the current is going to flow through the conductors and it's going to meet the load. It's going to go through the load and it's going to continue and it's going to continue until it finds itself back right to the power supply. So in this case, we have a closed circuit because the current, the electric current flows from one way and it has a way to find itself back into the source. So it's a closed circuit. If you did one of those, you break the circuit, then you don't have a closed circuit, you have an open circuit. All right. And if you did Instead of doing this, if you did one of those, if you run a wire between here and here, you would have something that's called a short circuit or shorted circuit. So the power supply is shorted. So over here, we are shorting the power supply. If we did this, yeah, run a conductor here, we would call it also there's a short circuit because over here we are shorting the light bulb, which is the load. Well, in this case, it doesn't matter whether we run the wire here or here, we are shorting the same thing. But if you had another light bulb here, and if you run a wire like this, then you would just short this bottom light bulb, okay? So here's an open circuit, here's a short circuit, here is a closed circuit that we have right now. Okay, so in order for things to work, for the electricity flow through the load, we are going to have a closed circuit. And there's no such thing as long circuit, because it's nothing to do with the way we draw things. It is how things work. So if we short the power supply or a load, the power supply or the load would be shorted, but we cannot make it long. We can't long it. Okay. However, there is such thing as long branch, short branch and long branch, and we talked about it a few lectures back. Okay. It has something to do with the length of the physical length of the conductor in the electrical installation. But it's not a long circuit, it's a long branch. So it's a different thing. Right? Okay, so in order for electricity, for the light bulb to be on, we have to have a closed circuit. Well, we're going to have to accomplish that situation with the three-way switch. What is the three-way switch? A three-way switch idea is that, well, we are using three-way switches, the one that we described it. And it's also, the system is called also a stairway system. Okay, stairway circuit. Let's say there's a basement here, and here is the first floor, and between that there are stairs. It's a set of stairs. Okay, and then there is a ceiling in the basement, and there's a ceiling on the first floor, and over here we have a light fixture that emits the light. Okay, and over here on the wall we have a switch, and over here also on top of the stairs we also have another switch. Now the idea of that is so you can control this light bulb with any of the two switches independently. You can turn it on and off using this switch, you can turn it on and off using that switch. And let me just here would be you walking on the stairs. All right, there you go. And here are your happy hands. All right, and you're walking up the stairs and you forgot to turn the light off. And do you have to climb back the stairs? No, you don't, because you can use the switch on top of the stairs to turn the light off in the basement. Okay, so there you go. So that's the idea of the whole thing. Now, there's also a possibility of using more than two switches. You can have one here in the basement, and you can have one further on the other side. But then in this case, you're going to have to employ something, not all of them, but you're going to have some of them in the circuit. You're going to have a four-way switch. All right, so you're going to have a combination of three-way switches and four-way switches, depending on how many outlets or switches you need to operate to control that one load. But that is you're going to do that during the next term. I'm not sure who the teacher is going to be. And in this term, we're going to learn the idea of a three-way switch. So it's just the two switches, two three-way switches connected to control one load. Okay, so let's see how we can do this. Remember, we said we're going to concentrate on, where's my multisim here? We're going to concentrate on this little guy, which is the single pole double throw, which also in our case is going to be called three-way switch. And what are the terminals? One is common, and we have two travelers. All right, cool. Here. All right. So how are we going to connect things? And there's a scheme that I do it. And I'm every time I try to explain it, I try to find a different way of explaining it until I perfect it, and I think I'm getting better and better at this. Let's see if we can do this. All right, so let's say we have the two switches. Okay. There's one switch somewhere here. There's common and two travelers. There's common. Here's a traveler. And here's a traveler. Okay. Now we have another switch somewhere here, and we're just going to position that a little bit different, the opposite, just for the simplicity of drawing. So we also have a common terminal here, and we have a traveler terminal here, and we have a traveler terminal here. And we have the single pole on those. Okay. There we go. All right, so the single pole can move between this and that, and this single pole can move between this and that traveler, right, independently. Okay, now also we're going to have, in order for us to have a circuit, we're going to have some sort of a load. So let's say we're going to have a light bulb. Here is a symbol of a light bulb. Okay. Let's put everything in boxes. So I'm just going to draw a dotted line to indicate that these devices are in device boxes. Okay. And there's one here. Okay. And then we're going to have terminals. We're going to have a hot terminal. We're going to have a neutral terminal. And we're going to have a bonding ground terminal. Okay. All right. So right now, we're going to concentrate on the functionality of things. Later on, we're going to concentrate, I'll also take a look at some of the code requirements that we need to do. But let's see the functionality of the whole thing first. So the scheme that I have, and you can use that in pretty much any situation, because sometimes the power is going to be provided to the first box of the run. Sometimes the power is going to be provided to the second box, which is the box in the middle of the whole run. And sometimes the power will be provided to the load box of the whole run. And we're going to have to connect it in the same way, but it's going to be, the wires are going to have to be routed a little bit different way, right? But this is the simplest way, just to show the idea of the functionality of a three-way switch. All right, so the scheme that I established today is connect the travelers. So one, travelers. Connect the travelers. Okay, can I make this thing bigger? There we go. And there you go. Position that in a way that is convenient. All right, so connect the travelers. All right, let's connect the travelers. Can we choose different color maybe? Here, I don't want to use green. Let me make it lighter blue. Here. All right, let's see how that works. Okay, so let's connect the travelers because that's what it says, right? Connect the travelers together. Here is a traveler connected to a traveler, and here's a traveler connected to a traveler. All right. Okay. Then we go enter and exit. Okay. Oops. Then we go enter, and we go exit. So let's do the enter and the exit. Here's the common and here's the common. All right, so enter with the hot to the common, and from the other hot we're going to exit, and that is going to go right into the load right here. All right, so what do we have here? Travelers, kaboom, kaboom, enter, exit, enter, exit. All right. Do we have a possibility of a closed circuit? No, we don't, because we still have to make the current be able to flow back to the neutral, because that's how it goes. Now, this is AC, alternating current, which means the current is not flowing only one way, it flows both ways. So let's say there's a direction of the current going this way, and there's a direction of the current going that way. So in the alternating current, the current flows just like that. And in North America, we have 60 hertz, which means it's 60 cycles per second. So the current changes the direction 60 times in 1 second in order to produce the current flow. Now, are we getting something? Let's say, we just moved it here, we just moved back here and back. Nothing happened. The current is, we still get the same electrons. Yeah, sure, but it takes energy to move the electrons back and forth, and as, as soon as the energy is being transferred from one place to another, we can make that light bulb, we can give that energy of the movement of the electrons into the light bulb. So now we can do that. So when we are looking at the arrows, we're just going to concentrate on one instant of a time, which is like a freeze the time, and let's see at which point the current flows which way. So let's assume that at the point of that, we just stop the time and the current is flowing this way here. Okay, so actually I'm just going to draw an arrow. Okay, so let's see if we have the closed circuit. Okay, we leave hot, we go to the switch. Oh, this is connected here. Okay, well, we can travel through the traveler conductor. Oh, we got a connection, we can go into the light bulb. Whoop, that's it. No more pathway. There is no connection between this and neutral. Well, you know what? Let's connect it. So here's the last thing that we need to do. Bring it home. All right, so travelers, enter, exit, bring it home. Sorry, I just touched my microphone. Bring it home. So what we're going to do, we're going to connect the other side of the light bulb or of the load. We're going to run it through the box here and between the boxes through another box, and we're going to bring it home to the neutral. Do we have a closed circuit now? Let's take a look. Leave through here, go through here, continue. Oh yeah, there's a connection. Go through the load, come back home right there. All right, we'll have a closed circuit. Well, what happens if we flip this switch this way? All right, do we have a closed circuit? We continue here, from that we go here. That's good. We continue that. Oh, whoop, nothing. That's it. That's where the pathway ends. There's no more pathway for us to continue on. The circuit is not closed. The circuit is open. Does the light bulb get electricity? No. So the light bulb is off. Well, we just turned it off using this switch. Can we turn it on using this switch? Sure, we can. And we are going to do it this way. All right. Do we have a closed circuit now? Let's check. I know we do, but let's just go through the motions. All right, so we continue here, go there, okay, blah, 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 here, go through the load and come back home. All right, so we have the we have the circuit that is closed. So now, can we also turn it off using this switch? Sure, we just turn it off by flipping it the other way. There you go. And now the light bulb is off. So you can control the light bulb from this switch independently or from that switch independently. So that's called a three-way switch. Now let's take a look at some of the conductors or the conduits, or both. Right, remember when we did, or you're doing it right now during this lab, you're doing the box offset, which is basically a piece of conduit that looks like this. And over here are the device boxes that the conduit is supposed to connect. So this here, this part that we're making during this is the second week of the lab, it's going to be this conduit that joins these two boxes. So you gotta watch the video that is in the description. And I don't want to use the down below. Here's the description. Okay. So this is going to be the box offset that you're going to connect these two boxes. And over here, you're going to have those three-way switches. Here's one three-way switch, and here's going to be another three-way switch wired in. All right. Then the little short piece of pipe that you're going to also get, it's got a 1-foot pipe, and that is going to connect that to the, and now I made a mistake in the 8 o'clock session. I called it the hexagon. It was a trip of a tongue. It's octagon box on which we're going to mount the lamp holder, to which we are going to mount the light bulb. Okay. And over here, we're just going to get the 2 screw connector that we mounted previously. And we're just going to get the NMD90 cable 14.2. And we're going to bring the supposedly power to it. So that's how this box is going to be powered. And over here are going to have single conductors going there and single conductors going there. And we're going to connect things. Now, let's see which, okay, so here is this conduit right here, and here is this conduit right here. All right, so how we're going to indicate that there's a conduit? We're going to just do it like this. Just by that kind of like elliptical kind of shape here. So here's a conduit joining these two boxes, and here's a conduit joining these two boxes. Now, in here, there could be a conduit or not, depending, but we're just going to indicate that there's some wires going in here. All right. Now, over here, how many conductors do we need and how many conductors do we need? So we're just going to make a little kind of a reference marker. So here we're going to use 3 conductors. And over here, I was going to do something else. Like it's going to indicate 3 14 gauge conductors, right? And over here, you can see conductor 1, conductor 2, conductor 3. All right. How many conductors do we need here? Well, we just need 2. Right. So here's 2 conductors. And if there were a conduit here from the electrical or the electrical panel into this box here, then we would just use maybe 14 2, okay, NMD90. All right. All right, so because the bonding as well, right? So here will be for 3, 3, 14, and there would be 2. And I'm just going to start the next line here. 14 conductors, and then you can specify the colors of what we need. All right, so what do we have here as far as the conductors? One thing that I want you to notice, please pay attention to the neutral. The neutral is electrically uninterrupted, and it goes to the load. So there's no switch going on between those. It just goes straight to the load. And that is correct because neutral is the potential of a ground. So if for some reason you come in contact with the whole thing with the system when the system is off, light bulb is off, you're not going to get shocked. Well, you're not supposed to get shocked. All right, now this here, the other side of the load is hot, is a hot wire, but we call it that it's a switched hot because sometimes, well, it is it's providing the hot pathway to the hot terminal, but is switched. So sometimes it's on and sometimes it's off. So that's why I call it switched hot. So the way we're going to conduct this lab is we are going to pull the wires. So there's going to be NMD90, pull them up to this box and leave certain length, a comfortable length for you to work later, and cut them off. Then we're going to pull the wires, single conductors, between this box and this box, leave a certain length for you to work with later, and leave certain length for you to work with, cut them off. And we're going to get two conductors from here, same thing, leave a length, cut off, pull it to here, leave it off, leave it and cut off. Now, somebody might ask, can we just run one long wire from the neutral location and through those pipes and to the load? Yes, we could, and it would work. However, I'm trying to give you the idea of working on the construction site, not on the countertop table. Right? So on the countertop table or on your ping pong table in your basement, if you're trying to make a project like that, yes, it would work. So what we're going to do is we're going to have that interrupted here. So there's a wire, there's three wires going to be pulled in from here to here. And what we're going to do is we're going to have a pigtail right here, pigtail, okay. And there's going to be another pigtail. So now you're going to practice doing pigtails in the box, okay. Why are we doing this? It's because the stages of the construction site or installation will be first, you'll be assembling the raceway. So you'll be running the conduits, mounting the box device boxes, running the pipes between them, and assembling all the raceway that we need to assemble before we pull the wires in. Later, the next stage would be pulling the wires. Okay. Now, assembling the raceway can last a few days. It can last a month. It can last 2 months, depending on the size of the project you're doing. All right. So then you're going to pull the wires, run the wires, install the wires, popularly called wire pulling stage. All right. So you're going to pull the wires from here, from the electrical panel into the first box. You're going to cut it off, leave it. Then you're going to pull the wires from here to here. And now these two boxes are not going to be 2 feet from each other. They're going to be maybe into different rooms, one downstairs, one upstairs, and it's going to be a long pipe. So you're not going to try to run the whole thing, because it would take you forever and you would just dig yourself in. So in order to make things nice and proper, pull the wires, cut them off, pull the wires, cut them off, pull the wires, cut them off, and then, well, possibly label them. And then the next thing should be the termination of the wires. So that's why we got pigtail here and make a pigtail right here. Uh, so that is the that's what we're going to do. So the pipe that you're keeping here, you're going to bring it and you're going to get those two boxes, light bulb and so on. All right. Am I forgetting something? Probably not. Yeah. Now, before we finish off today, I just want to remind you that there's going to be a quiz, and the quiz is going to be let's see the content. course outline. Here, see, there's week 11 right now. Quiz, weeks 8 to 11. Weeks 8 to, well, we're going to make it weeks 8 to 10, right? And then we're going to continue. So weeks 8, 9, and 10, there's going to be a quiz. And then the test is going to be week 14, is going to be week 8 till week 13. All right. So just keep that in mind. And watch those videos that I'm asking you to watch before the lab 4. So just watch the two, using the hacksaw and making a box offset. So the second half of the class is going to do the box offset. And okay, one thing I want to mention to you: please do not get discouraged if you don't get the pipe bending right at the first time. You will rarely get that. If you get that at the first time, it's a beginner's lack. Assume that. Or sometimes you're just natural, or sometimes maybe you have done it and you're not telling me. All right. So there's a process of going through that, handling the pipe. You can watch a million videos, but you won't be able to do it until you actually put your hands on the pipe and put your hands on the pipe bender, put them two together and start bending. And then there's that spring back you have to deal with. There's all kinds of other things that your muscles have to get used to, your body has to get used to, your hand to eye coordination has to get used to, in order to develop the proper muscle memory so you can go through the proper motions. And the only way of learning how to do this is by doing it. So you will not get this thing right first time. You have to go through that process. Everybody goes through that process. Okay, so here was my speech. Right. So, oh yeah, one thing I'm going to mention is that the assignment that we're going to do is going to involve 3 scenarios. This is going to be the first scenario, where the power is provided to the first box of the run. The second scenario will be the power that is provided to the second box of the run. Or there could be a third scenario here, that the power is provided to the box where the light bulb is, which is the load box. The wires will have to be run slightly differently, but if you keep to this scheme right here, connect the travelers, take care of the entrance, take care of the exit, bring it home. So connect the travelers, traveler to traveler, hot to load, which is enter the system, entrance, which is the first switch to the common, and then the other common goes to the load. So enter, exit, and then bring it home, bring that home. Now, in some cases, you are not going to have a neutral wire going through all the boxes, because in this case, the neutral is in this box. Yes, it is. Is the neutral in this box? Yes, it is. Is the neutral in this box? Yes, it is. But in some cases, we have different combinations of power being supplied to different boxes. You might end up with the neutral not being in one of the boxes, which means we're going to have to bring it there and just blind it with the wire connector. So the neutral has to be in every box available to be used, even if it is not used to make this particular system functional. It's the code for now, right? So what I want you to do is just take a look at this and see how you would use this scheme here, this order of things, to connect the same circuit, but the power provided to, instead of to first box, power provided here, or power provided to here. Use that and see what you can come up with. So just get yourself ready for that. And then later on, we're going to take a look at that, how it's done. But I want you to, I want you to get your thinking started that way. All right. Okay, so that's all said and done. I said everything that I needed to say in this presentation. And as I said to the other guys at 8 o'clock, on this happy note, because it is almost Friday. I know it's Monday, but as I always say, every day is almost Friday. And with that attitude and happy thought, I'm going to say, see you when I see you. And thank you for joining me this afternoon. All right. Bye, guys.